Hi folks, so in this video what we're going to do is we're going to complete this question here based on the topic of the ellipse, okay, and this question specifically came up in the 2024 Junior Cert Graphics exam. So the question here says, shown on the right is a dimension drawing of a toy helicopter, and you can see all the dimensions here. The curve ABCD is an ellipse, so if we look at it, A to B to C to D, that is our ellipse there. BD is the minor axis, so you can see down here they give us the minor axis from B to D. They give us that distance there so we can draw in our minor circle. And F1 and F2 are the focal points of the ellipse, F1 and F2. OT is a tangent to the circle, so if you look at the drawing from O to T here is a tangent. Okay, it tells us part 1, the length of the minor axis BD and the focal points F1 and F2 and the position of the major axis are given below. Find the length of the major axis and draw the ellipse. So they tell us the exact length of the minor axis from B to D, okay, with the center point here. So can we draw in the minor circle? Yes. So if you position your compass here, pencil up to B, I'll just always check it here that I can get it accurate. Yep. So I'm going to draw that there, and that there is my minor circle. Okay. Now the question states, find the length of the major axis and draw the ellipse. Now, lots of students might assume that the length of the major axis is out to here and out to here. So if you put your compass here and pencil here, draw a major circle. Now, that is not correct. All they've given us is the direction of the major axis, which is always going to be perpendicular to the minor axis. Minor axis vertical, major axis horizontal in this case. Now, how do we work backwards to find the major axis? They give us the focal points and they're there to help us to work out the major axis. Now, usual method here, if you were given the major and minor axis, how would you find the focal points? You would take half the major axis and put it at the top of the minor circle and swing an arc to cut the major axis, and you would find your focal points. So we can use that principle in reverse, where we can take the distance from the top of the minor axis to the focal points. So from B out to F1, I can take that distance and apply it backwards. So take the distance from B to either focal point, or D to either focal point, it will be the same distance, and then that will be the radius of my major axis. Now I can draw in my major circle. And there we go. I've now drawn my major circle. Now what we're going to do to draw our ellipse is do the concentric circles method. So 30 degrees through the centre, 30 degrees through the centre the opposite way, 60 degrees through the centre, and 60 degrees through the centre the opposite way. Now, rule of thumb, wherever any one of those division lines cuts the major circle, I'm going to go parallel to the minor axis. Where any one of those division lines cuts the minor circle, I'm going to go parallel to the major. Now, we've already got 4 points in our ellipse. At either end of the major and minor axes are 4 points. So, those 4 points I've just highlighted there. Now, all I'm going to do is, anywhere it cuts the minor circle, I'm going to go parallel to the major axis. The major axis is running horizontal, so it means I either go left or right. So I'm going to go left and right, left and right, and up here to the top half, left and right, and likewise here, left and right. And now, anywhere any of those division lines cut the minor circle, I'm going to go the major circle, I'm going to go parallel to the minor axis, which means I'm either going up or down vertically. So down, up, and on the bottom here, up, down, likewise here, and here. Okay, and there I have it. I've got all my points in the elliptical curve. And all I'm going to do now, I like to put just little dots of them, so I kind of have a little guide. And what we need to do is I take it quadrant by quadrant and I'm going to start sketching that in. So nice and light, I'm going to do it with my pencil first. So from point to point, we're trying to make it flow in one smooth pattern. So there's one quadrant. Move around the table as you need to. There's our second. Okay, so there's the top half. Now working backwards. And very important here, there is marks for the presentation, so you're trying to make sure that it's not hatchy. Okay, And you'll see here now when I go over it, just using my pencil here because I'm going to use a marker in a second. Now obviously on the day of the test you're just going heavier with your pencil. For demonstration here in the video I'm using a marker. That's my little guide. And now what I want to do is go between each one. I'm trying to make it a nice smooth curve. Okay, I have my guide. I messed up there now. Take my time with this little bit here. Flow in. Now we're on to the bottom half. Okay, so nearly there. Okay, and there is our elliptical curve. Right, now what we're going to do is we're going to move on to the legs, okay, down here. So you can see from D, how far is it down, I suppose, to the rail here at the bottom. You can see from here down, it's a measurement of 10. Okay, so I'm going to measure down 10 from D. So I'm going to draw a line down from D, and I'm going to measure down 10 millimeters as far as there. So there's 10. I'm going to do a line horizontal, left and right. Now, I've done my measurement down from D, I've measured down 10, done a line left and right, and from here I'm going to measure, from the middle I'm going to measure out 35 and 35, and that's going to help me get the legs of the helicopter. So from the middle, 35 out, actually works out nearly pretty much bang in line with one of my division lines. So it is. Okay, so I'm just heavy in about that much there. Now it goes a little bit further, and I'm going to heavy in the division line. Just so happens that it happens to hit exactly on it based on the measurements. And now what I need to do is I need to get the kind of curved portions here at the end. So how do I get those? Well, the center points are here and here. And what is the radius? Well, if the center point is here and then the curve starts down here, the radius is obviously 10 also. Okay, so what we need to identify is the center. Now the center is in line with D. So from D, I'm going to do a line left and right. Okay, and then how do I find the center? The centers are directly below the focal point. So from F2 I'm going to go down and F1 down. So from F2, do a line down. That's going to be my center here on the right hand side. And from F1 the exact same thing. I want to do a line down. Now I'm going to extend those lines down, actually to the bottom line, because that's going to identify to me how far I can heavy in that bit and that bit. Okay, now that I've that done, I'm just going to use my compass here. Put my compass on the center point, pencil out to here, and put in my little arc. Okay, I'll go back over it at the end now with different compass using the marker. And there's my arc on the right hand side. Okay, so I've got the legs done. I'm going to heavy those in right at the end. Now what I want to do is I want to work up here to the, I suppose, the helicopter kind of wings, okay, or the little the spokes bits here that obviously helps the helicopter fly. Okay, so from B, what I want to do is I want to go up here and find this point. So that there, how high is it up? It's up a height of 15. So from B, I'm going to measure up 15, do a line up, and I'm going to measure 15 millimeters up. I'm going to use the 10 as my measuring part. So from 10, I'm going to go up 1.5, so that brings me to 11.5. The only reason I'm not using the 0 is because my visualizer is in the way. So I'm going to do a line up there. I'm going to measure up as far as the 15. That's my 15 mark there. Okay. Now what do I have to do? Well, I have a line that goes out here, and once again it's in line with the focal points. So this time I'm going to bring the focal points up. So they'll go up and up, and from there, I just move my set screw out of the way here, top here, line out left and right, and let's get that. Okay, so that's that there. Now what we have to do is we have to get this little kind of window portion in for the helicopter. And you can see here that it has a radius of 30. But more importantly, it's identifying where does it touch. It touches right here. This is one point that it touches there, just highlighted on the actual drawing. Touches right there, okay, and it also touches right here. Okay, so I have a radius 30 that touches this point and this point. So I need to find those 2 points. How do I find them? Well, one is directly up from the leg. So if I continue the leg up, that's one of them right here. And then that will actually identify to me, because I can actually heavy in this line here going across. Okay, so that's one of the points I found literally right there. Okay, the other point I want to find is from here. If you join this point here all the way up to the top of the line where B was, I can make that little line there. And where it cuts through the elliptical curve will help me find it. So if I join this point here at the top of the helicopter, down to that one, you can see there we've created that line, and where it cuts through the ellipse, I can get that point. And it cuts through the ellipse right here. Okay, so there is my second point. Now, all I have to do here is I have a curve that has a radius of 30 that touches these 2 points. So the center point has to be out here in the open space somewhere. How do I find that? So what I want to do is I'm going to get 30 millimeters on my compass, a radius of 30. So I'm just going to use my T-square here. I'm going to start it at the 30 mark on my T-square. I know it's a bit dark, you can't see it there, but I'm going to measure out 30 millimeters on my compass, just like that. Okay, 30 millimeters on my compass. Now I know it touches this point and this point. So therefore the center has to be 30 millimeters away from either point. So I'm going to swing an arc. The arc has a radius of 30 into the open space. I'm going to take my compass, I'm going to swing an arc from the opposite point, and where the 2 points intersect is my center point. Now what I'm going to do is I'm going to use that distance there, that is my center, and I'm going to swing an arc, and the arc should cut into both of those. And once again, I'll heavy in that detail at the end. But there we go, there is our little window. Now we're on to the tail portion of the helicopter. So from the tail, you can see that the tail goes from B out to here, and we need to find the center point. The line OT is a tangent, so lots of students might think that literally from O it literally connects to this position right here. Let's say the 6 o'clock position on a clock. It doesn't. It actually connects a little bit further out, and we have to do the principle of a tangent there. So let's start that. From B, line out like this, okay, and I want to find the center. How do I find the center? Okay, it doesn't really tell us the measurement up here, but if you come down to the bottom, see this little measurement here of 45. So from the edge of obviously the rail here at the bottom, I can measure out 45 and draw a line up. So you can see this point down here where the curve finished. From there I can do a line out. I'm going to measure on that line 45 millimeters and then do a line up. At that point right up here, that's my center point. Okay, what's my 2 radiuses? I have the radius for the inside circle, which is a radius of 15. Okay, so we're going to do that. So I'm going to get 15 on my compass. So off screen here, bring it up. From the 40, I'm going to the 41.5. That's my radius 15. Okay, I'm going to draw on my circle. Nice and quick. Neat and tidy. Okay, there is my 15 radius circle. Now what I want to do is I want to get a tangent to that. So how do I do that? Principle of a tangent. Where does the tangent come from? It comes from the center point of the ellipse, O, okay, and it's touching out here somewhere. So what do I do? Wherever the tangent comes from, I connect it to the center of the circle that I want to join it to. So I'm going to join a line like that. What do I do with that line I've just created there? I have to bisect that line. So putting my compass on the center of the circle, I'm going to set a distance greater than halfway. I'm going to go nice and big now, because there's kind of a lot going on here. I'm going to go nice and big. I'm going to swing an arc above the line, below the line. Now I'm going to go to the other side and go to the center of the ellipse and swing an arc above the line, below the line. You can see here I just actually need to extend that one a little bit further. And there we go. So where the 2 arcs intersect above and below, here and up here, I'm going to join those. And all that's going to do is it's going to give me the perpendicular bisector, but it's going to give me right here the middle point of that line that I did. So step 1, join it to the center of the circle from where the tangent starts, bisect the line, and now that I've got the bisector, put your compass in the middle, set your pencil on the compass to the center point of the ellipse, and that's the radius for a semicircle, which will actually cut through the circle here. So watch this, I'm going to do the semicircle at the bottom half. I'll show it to you here. And there we go. And you can see our semicircle, where it cuts through the circle here, will give us what is our point of contact, or in this case, as they call it on the sheet, point number, or point T. And we've got O in the middle. So now I can join O to T, and that is our tangent line. Now what bit do I heavy in? I heavy in the bit from the ellipse to the outside. Okay, so lots of people assume the touch is there. It actually touches just a little bit away, okay, from the bottom of the circle. So now that we've got that, we're going to start heavying in the rest of the details. That's a lot of the hard stuff done. It's just a case of finessing the rest of the object. So from here, from B, goes to the outside of the circle there. Okay, and then I have another circle to do, a radius of 30, as we can see up here. That's going to help us get these little kind of small little, I suppose, little propellers, okay, at the end of it. Not really sure what the name of them are. So I'm going to get 30 on my compass. And going to use the same center because it's concentric circles. So radius of 30. Okay. And now what I'm going to do is I'm going to do a line up. That's going to give me the vertical one. But then there's two going down here, and you can see the angle says 120. So 3 120s. A little bit of maths. What we're going to work out is the angle going downwards is actually 90 plus 30, which is 120. So 30 degrees down to the left, and we flip it over, and also 30 degrees down to the right. And now we would heavy in that bit there, heavy in this bit here, and also the vertical line here. Okay, there's those little bits. Now just going to switch out to another compass here, so I can heavy in the details to make it look better. That's the question essentially done though. And in any one of these questions you will get marks for presentation and neatness. So obviously you're always trying to highlight the actual shape because there is quite a lot going on here. So as best I can, using my second compass here now, try and do this without slipping. So there's that bit there, and now we're going to go down here, and I'll do this as best I can once again. Quite hard to do it when it's so small, but we'll manage. So there's that bit there on the left, and same thing with here, this one on the right. Just dig it into the table. And there's that bit on the right. Okay, and don't forget this bit here for the window. Just position it there. Just going to check, yeah, happy with that. And there we go. Okay, so there you have it, folks. Just checking over the question here at the very end. I've got the top portion. Just forgot a line there. Actually realised, apologies, forgot to heavy in this line here. So that line right there just needs to be heavy in. So I've got the top portion, I've got the window, I have the ellipse, I have the legs at the bottom, and I have the tail. Okay, so there you have it, guys. That there was the ellipse question from the 2024 graphics exam. Hope you found that helpful. Okay.